Alright, so when you're solving linear inequalities, a lot of times you'll get a solution set, like x is greater than 5. So any number that's bigger than 5 would count as a solution for that inequality. Sometimes there's no solution. That's where you work the equation until it tells you something that's definitely not true. Like 10 is greater than a billion. That's not true. So if your inequality works down to something like that, then you know that there's actually no solution. Um, Sometimes your solution is all real numbers. That means, well, and for our purposes, that basically means all numbers. All the real numbers are anything that's not an imaginary number, and you most likely have not learned about imaginary numbers. Yeah, the I is an imaginary number. That's the square root of -1. And so, anyway, don't even worry about that. So, all real numbers is anything except for the numbers that have to do with this I business. So really, it's any number that you've heard of, basically. So what does that mean? If we were gonna graph the solution set to um, an inequality whose solution is all real numbers, then what would that look like? Actually, um, you have your number line here, and you could, I don't know, you could pick any number. Let's say 12. Um, and your solution would be just uh, it would just it would go infinitely in both directions. I mean, this could be the number 120. It could be 1200. It could be 12,000. Whatever. Your solution would be any number that's on this number line, right? So how do you tell? Basically it's saying what works for this inequality? Anything works. Anything goes. It's not restricted to, x has to be greater than 5, or x has to be less than -3, or x has to be between -3 and 5. It's any real number works for this inequality. So how do you tell? Well, here's here's the clue. Look for stuff that's true no matter what. That's kind of how I break it down. If you work with an inequality and get down to something that's obviously true no matter what, um, the absolute value of x is greater than or equal to 0. For example, that has to be true. You can plug any number in for x, and that inequality will be true. Um, because uh, absolute value, the absolute value of something has to be 0 or greater. Because absolute value means distance from 0, so you're never going to get a negative number, basically. Um, or if you work with an inequality and get it down to something that says something just totally obvious like this, 100 is greater than 3. That means you can plug any number into the variable in the inequality, and it'll work out. And then finally, there's a case where if your conditions are x is less than 5. Let me just graph this. Less than 5. So we've got 5 here and 2 here. If anything less than 5 will work, and anything greater than 2 will work. These things overlap. Uh, so, any number will fit these conditions. It's not a very restrictive condition to say your number has to be less than 5, or it could be greater than 2. Um, you know, 1 would work, 3 would work, a billion would work, negative a billion would work. All real numbers will fulfill these conditions. If that makes sense. Okay. Um, so let me just give you some examples of some inequalities uh, whose solution set is the set of all real numbers. And by the way, the way to just state all real numbers, instead of spelling it all out, you could capital R stands for the set of all real numbers. I don't know if you can see this, but sometimes it's kind of like this R that's not filled in. That's terrible. That's like a profile of a duck. Um, okay, so let me let me stop drawing and actually solve some things here. Okay, 2x plus 10 is greater than 2x. Well, just I mean, let's look at what this means. 2 times a number increased by 10 is greater than 2 times that number. And so this will be some value, and this will be equal to whatever that value is. And so it's saying if you increase this by 10, it'll be bigger than if you don't increase it by 10, which is just obvious, right? So, and I'll just I mean to prove this to you, I could well, you know, let's solve this inequality. So let's get all the x's on one side. So I want to move these x's over here. So I'm going to subtract 2x from both sides of the equation. 2x minus 2x, oh, that's 0. So everything that's left here is just 10. 2x minus 2x, that's also 0. So I get down to 10 is greater than 0. That's a situation like this. You know, something that's obvious, just something that has to be true. So I could plug, that means I could plug any number in for x. Let's say I plug a billion in. So 2 times a billion. So 2 billion plus 10 is greater than 2 billion. Yeah, no kidding. How about negative 5? So 2 times negative 5 is negative 10. Negative 10 plus 10 is greater than negative 10. Yes, very true, no matter what. So the solution to this inequality is all real numbers, the set of all real numbers. So yeah, okay, so work with the inequality until you get down to something that's just, you know, true no matter what. And then you'll know it's an inequality with an infinite number of real number solutions, and in fact all real numbers would count for that. Alright, so let me just do another one here. So, you know, this to me is not as immediately obvious as this one. You know, this one, 2 times a number increased by 10 is greater than 2 times a number if you don't increase it by 10. This one is not so clear, so I'm just going to follow the rules of algebra for a bit and see if I get something that's, you know, of this nature, where it's just, it has to be true no matter what. Let me get some room here. Okay, well, let's just distribute this 5 first. Let's deal with those parentheses. So 5 times x is 5x. 5 times 2 is 10. So we've got 5x minus 3 is greater than, or is less than 5x plus 10. Maybe I'll add 3 to both sides when you get 5x by itself. 5x is less than 5x plus 13. At this point, maybe you're thinking, I don't know, that looks pretty suspicious. 5 times a number is less than 5 times a number increased by 13. Yeah, I mean, that seems to make sense. Seems like you could plug any number in and that'd be true, but just to keep going, to make it that much clearer, I'm going to subtract this 5x to get it over to the other side so we can get the x's together. Well, when I do that, 5x minus 5x is 0. 5x minus 5x, that's 0 again, so I've got 0 is less than 13. So that's, whoa. So that's true no matter what. So then I know that the solution set to this inequality is just all real numbers. So I'll let you try this one. Don't be intimidated by this huge number. It'll work out to be something like this. You know, just do the work and show that it has to be true no matter what you plug in for x. So when that's the case, then the solution set is all real numbers, which you can symbolize with that r like that. Alright, have fun.